So far this unit we have recovered Pythagoras. As I said, we have started trigonometry and we have learned how we name triangles in the big people world of math. All right, A, B, C are the corners. They're capitalized because they are the vertices. What side is this? Little a. What side is this? Little b. And what side is this? Little c. That's the way you're used to seeing it because of a squared, b squared, c squared. Right now, before yesterday, all you could do with this was you could tell me the third side. And what was the third side? C equaled the square root of 9 squared plus 16 squared, which is the square root of 81 plus 16 squared is 256. Which is the square root of 387. Is that right? Square root of 387. Yep. Everybody cool? That's what you could do up until yesterday. Yesterday we discovered that this, if I compare these two things, 9 divided by 16, that gives me a decimal if I do that. That is a ratio. When I compare the two legs, I get what is called the tangent ratio. And that tangent ratio can also be written as the decimal 9/16. Which is 0.5625. Now, that ratio exists when I compare the opposite to the adjacent side of that angle. So that equals the tan of A. If I move up to B, then the tan of B is 16/9. Now, if I change this angle, I'm going to change the length of one of these sides, this one or this one, which means the ratio and the decimal will change as well. That's where we sat yesterday. So let us go to page 238 and discuss angles in the real world. There are two things we must discuss here. So far, we've been practicing trig with triangles drawn on a piece of paper. Those are not the real world. Behind you is a giant triangle that was on a piece of paper that was built into this school. That is what we use trig for. So, in the real world, there are a couple of options. The first one is the easy one. Everybody, well, you don't have to draw it this way. I don't really care how you draw it. But I am going to draw an eye there. That's a bad eye. All right. Your eye looks horizontally, unless it sees something that it would like to see. The first one we are going to discuss is what happens when your eye sees something up in the sky. Plane. Everybody looks up when they see a plane, doesn't matter what they're doing. You hear a plane go over, everybody looks up. So where does your eye go? Up. So you're going to look up here. Your eye was down here, now it's up there. It made this angle. Yes? This angle is called, since it's an angle we're talking about, we're going to call it theta. And it is what is called an angle of elevation, or inclination. because your eye is going up. It is inclining. It is making this angle from flat to up. And notice the angle lives between where the line is flat, horizontal, and where it goes up to. Does everybody understand? That's the easy one. Okay? Everyone's cool? All right. Now, obviously, if your eyes can look up, where else can they look? Down. On the ground, your eyes see a $5 bill. You are looking straight forward. You then look down when you see the $5 bill. Where is the new angle? Here's the ground, where the $5 bill is. Where is the angle that we would be caring about? Where would it be? Between what and what? Between where? Between the horizontal and the red line. This is the angle I care about here. This is the more difficult one for kids to wrap their brains around because you've been practicing with triangles drawn like this, right? So that looks just like the angle of elevation. But if I bring this triangle down here, that's not an angle of, it's not this angle, is it? But if I flip that, now it's the same angle, isn't it? And yet, kids have trouble with this one. This one is called the angle of depression or declination because you are looking downwards. Does everybody understand? It's problematic because all of you want to put your angle of depression over here, which it is not. All right? Now, this is the other reason this becomes difficult. Let's pretend up on the plane there's somebody up there looking downwards at this guy looking at them up in the sky. So this guy's eyes would go this way, wouldn't it? So where would his angle be? It would be there. Is that an angle of depression or elevation? Depression. It is the same as this guy's angle of elevation. Does everybody understand that? If you make a rectangle, some teachers teach this, and they call it the Z rule, because it makes a Z. And these two angles are the same. Everybody cool? An angle of elevation going up equals the angle of depression from the up to down. The mistake you guys all make is you put an angle of depression over here, and that's wrong. Is everybody cool? All right, that's only half of the angles in the real world. On the bottom side of your page, split it in two. Now, all of you have watched movies. You have all heard this before, especially war movies. He's coming in on a heading of 83 degrees, something like that, yes? We've all heard that, right? That is based on direction. So everybody draw a compass here. In math, or not in math, when we represent a compass, what direction do we put at the top? North. No matter what, right? So right now, according to this drawing, if I walk straight down this row, I'm walking north. Of course I'm not, am I? If I walk that way, I'm actually walking west, but that's not important. On the paper, in the drawing, if I walk straight that way, I'd be walking north. Everyone agree? Okay. North is problematic. North is 0 degrees. If I walk on a heading of 0 degrees, I'm walking straight north. Everybody cool? What's right here? East. Now, that means if I walk straight that way, how far am I away from north? How far is that? 90 degrees. So if I tell you I'm walking on a heading of 90 degrees, what direction am I walking? Straight east. You're smart kids. What's this one? 180 degrees, and that is straight south. What's this one? 270 degrees, and that's straight west. Everybody should be cool with the straight ones, right? All right. So if I tell you I am walking at a heading of 73 degrees, in which quadrant am I walking? Yellow, blue, green, or pink? I am walking in the blue one, yes? And am I walking on my drawing? That is northeast, which would be how many degrees? 45. Am I walking on the blue side or the yellow side of northeast? The yellow side, because I am walking out here at 72 degrees. I start at 0, so that is 72 degrees. Do we all understand? Have I made a triangle yet? Can I do trig yet? No, I would need a triangle to do trig, right? If you were trying to find out how far I walked and we were going to do trig, you would need to make a triangle, yeah? So you could make the triangle here, right? Or you could make the triangle here. This theta is what? No. I'm walking on the ground. I'm not flying in the air. This, I am walking at 72 degrees. So how far is green theta? North is 0. East is 90. How big is the green one? Jacqueline? 72. Right? Because I started at 0 and I went to here. Yeah? Everybody cool? But what if at this point I turn this way? Then don't I need this blue theta to do my trig? And what value is that? How can that be 72 and that be 72? 18. Why is it 18, Emma? Because it's 90 minus the 72. Does everybody understand? All right, let's see if you really understand. Say a number between 0 and 360. 240. I am going to walk at a heading of 240 degrees. Where would that be? Southwest, somewhere down here, yes? So, if I start from 0 and I go all the way around, this is the 240 degrees. Does everybody understand? Can I do trig with that? No, because I don't have a triangle. I can make a triangle there, which would mean I could do trig with purple theta, yes? Or I could make a triangle there, which means I would do trig with red theta. Right? What is purple theta? 30. Why, Rylan? If I'd gone all the way to west, it would have been 270, but I only went 240, so this must be 30. What does that make red theta? Red theta is 240. I want to be able to do trig, which means I need a 90-degree triangle. What is it? 50. 60. Why? Because this is 30. All the way between south and west is 90. So what's left here must be 60. Does everybody understand? Now, I can't remember which is which. One of these things I am teaching you, people call it a heading. And what I'm about to teach you over here in the white, people call it a bearing. I can't remember which is which. It doesn't matter because they're used interchangeably. Okay? This one goes from 0 degrees, which is north, up to technically 359, which would almost be straight north. Does everybody understand? So no matter what I say, you're going to be somewhere in here, and then you make 90 degrees to do trig with it. Everybody cool? All right. The other way starts exactly the same. So draw another compass. Draw north, east, south, west. And this way is slightly different. This way, when people give you directions, it is in this scale. It will have a direction, then a number, then another direction. So somebody say a direction. West. Now somebody say a number between 0 and 90. 72 and north. What that means is this is your start, this is your adjustment, and this is the direction of the adjustment. Okay, I'm going to change that north to south. All right? So where do we start? Right here. Everybody cool? We always start in the middle. Every time we turn or make a direction change, we are back to this starting point. Now, what direction is straight west on this drawing? 270 straight left, right? Forget the 270. This way would be west. Agreed? Did I walk west? No. I adjusted 72 degrees in which direction? South. Where's south? Down. So I adjusted 72 degrees south. Does everybody understand? And that makes this triangle that I could do trig with. What is this in here? 18. Everybody cool? So I'm going to give you a direction here. You tell me, you draw the line on here and put in the two angles. Is everybody cool with that? All right. So I want you to draw me a line at north 18. No, we've already done 18 and 72. North 27 east. Where would that line be? I always start in the middle and then go from there. How should I draw this? He waited patiently. Jacqueline. So north is the direction I should have started. So I should start up this way. But I didn't walk north, did I? I adjusted 27 degrees in which direction? To the right. So there is the 27. There's my line. If that's 27, what's this? 63. Now, isn't this east 63 north? Yes. Does everybody understand? Now, normally we would split it at 45, right? If we've gone past 45, we wouldn't say north 50 east. We would say east 40 north, because 45 is the halfway. Is everybody cool? But they're both the same thing. Everyone is good with that? So, if you see something to do with direction, right? Like he walked off at 18 degrees. Are you going to be using the left or the right? I'm going to walk from this point on a heading of 18 degrees. Left or right? The right? This one? This one needs direction, number, direction. I said I'm walking away at 18 degrees. So it's going to be the one on the left, right? The one on the left, correct? And if I told you I'm going to walk west, south 18 degrees, I'd be doing this one over here, right? If I wanted to walk off at 18 degrees, I would be walking right here. Much closer to north than east. If I wanted to walk west 18 degrees, west 18 south, I would be walking down here. And this would be the 18. Is everybody good? All right. Now listen to me. You're not going to work on it right now. Page 239. You can now do all of it because you know about elevation and depression. So this is work 1. Please turn the page over to page 240. And very quickly we are going to draw a triangle. Give me this angle of 67 degrees. And I'm going to tell you this side is 14. And I want to know that side. Right now, I'm going to put a Y there. Right now, the only way you can find x is by doing tangent. Yes? All of you who were here yesterday. And we do that the same way every time. Theta is any angle I care about. Sometimes it's unknown. In this case, it's 67 degrees. Now, that means this is the angle that I'm viewing the triangle from. So that x, since it's across the triangle, is opposite. It's x. This, since it's the other leg, not the hypotenuse, is the adjacent side. And we know that tan of any angle always equals the opposite over the adjacent. Put in the numbers I know. Tan of 67, because theta equals 67, equals x over 14. And to get rid of divided by 14, 14 times tan 67 equals x. And that you do on your calculator. Only then do you touch your calculator. Everybody good? So now you would punch that into your calculator, and depending on the kind of calculator you have, you would get 14 tan 67. See, I don't even need to push times on mine, but I gotta close the bracket. And now I know that side is 33. Well, 32.98, which we would round up to 33. It's too bad that happened, actually, because, normally our sides we would round to the nearest tenth. And our angles we round to the nearest degree. But this has to round up to 33. Everybody cool? Well, now, since I know what x is, I've got it right there, I could find the hypotenuse, right? Now, you're smart kids. There must be a way to find the hypotenuse, just like we use tan here. There is. There's two other trig things we can do. The first one is sine. Sine compares the opposite. What does opposite mean in trig? Across to the hypotenuse. Everybody cool? So in this triangle up here, it would be sine 67 would equal x over y, because x is opposite and y is the hypotenuse. Everybody good? Now, again, you're intelligent young people. If sine uses the opposite in the hypotenuse, what must cosine use? The adjacent and the hypotenuse. So in this question, sine 67 would equal 14 over y. Which of these two, blue or green, could we do? Not sine, you idiot. Cos. Which of these two, blue or green, could we do right now? I could do cos right now. Since I know what x is, I could also do this one. But right now, I can do this one. Everybody cool? All right. Now that sets up this fake word. It's not a real word. It's a fake word to remember this stuff. S stands for sine, which on your calculator is sin, the sin button. And sin is opposite and hypotenuse. C stands for cosine, which on your calculator is cos, adjacent and hypotenuse. And we already have worked with tan, is opposite over adjacent. Now, let's put all this into use on a triangle. We are going to draw our triangle weirdly here, not the way we're used to seeing it. Everybody cool? All right. 3 letters, please. That's not a letter. That's a sneeze. X, Y, Z. X, Y, Z. Now, what does that make this side right here? Little z. What does that make this side right here? Little y. And what does that make this side right here? Little x. Now, listen to me carefully. Tell me the sine of big X. Where does that mean I'm looking at the triangle from? Am I looking at it from this corner? Am I looking at it from the pink, from the green, or from the yellow corner? If I want the sine of X. The pink corner. Good job, Addison. So that means I am working up here. X means I'm working there, right? Now, what is sine? You just wrote it down. It's right here. What is sine? Opposite over hypotenuse. What does opposite mean? Across. So what do you see that is across from the pink corner? Little x. Over, what is the hypotenuse? Y. If either one of them is a number, we can write it in here. Does everybody understand? Everyone is cool? All right. Well, now tell me what is the sine of z. Where am I looking now? From the z corner. Sine is always opposite over hypotenuse. So what is the sine of z? Z over y. Ease, peas, lemon squeezy. If one of those is a number, we can put it in here. Right? Okay, you're intelligent young people. You're doing very well. What is the cosine of x then? Cosine is right here. I've done it in red. Cosine of x equals z over y, adjacent over hypotenuse. What is the cosine of z? X over y. Please notice the sine of one is the cosine of the other. Notice we are not talking about the 90 degree here. This stuff only works when with the acute angles. Jacqueline. Okay. Then what is the tan of x? So close. It's written right here, ladies and gentlemen. I'm going to wait. Look at everything you've done. Put it together. Especially if you're here yesterday when you've already done tan. This should be the easy one. I got 45 more minutes, so I'm just going to sip my coffee until somebody can figure this out. Tan of x is? What'd you say, Braden? First Braden? Braden S? X over z. Is that opposite over adjacent? I'm asking if this is the opposite side of x divided by the adjacent side. Yes. Okay. What then is tan z? Yeah, you said it right the first time. I was looking at z. Z over x. Notice that in tan, you never touch y. You never touch the hypotenuse. So if you were seeking the hypotenuse of a triangle, would you ever use tan? No. Other than that, you set all of these questions up the same way. So let's look at this first one. We know we're dealing with an angle here, right? So we have a theta. What is it? Theta, for those who were not here yesterday, is a Greek letter. It's the letter TH, really. It means an angle. That's all it means. It's the letter, the Greek letter that math guys have decided refers to an angle. We have an angle right here, so this is 12. Once we have set this as our theta, that means this is the corner that we are working with. So this sets our opposites and adjacents. Does it have anything to do with the hypotenuse? No, because the hypotenuse never changes. So once we are set up in this corner, I have to look. What do I have in this triangle? I have a hypotenuse of 25. What do I need in this triangle? I need that x. And since I've looked across the triangle, that must make this what? Opposite. What uses O and H? Sine. Sine theta equals O over H. Now just fill in the numbers. Sine of what? No, we know what theta is. Sine of 12 equals what's O? X over hypotenuse. What's hypotenuse? 25. And then, how do we get rid of divided by 25? Multiply. So 25 sine 12 equals X. Now, and only now, will you pick up your calculator. If you were here yesterday, you already know how to punch this in. If you were not here yesterday, you need to figure it out. Remember, are we going to hit the tan button this time? What are we going to hit? The sin button this time. Depending on your calculator. If your calculator prints the word sin when you hit that button, then you punch this in exactly as you see it. 25. Some of you may need to push times, but most of you probably won't. 25 sine 12. Then you may need to close the bracket, then hit equals. If you are the other way, you reverse that order. Exactly reverse it. 12 sine times 25 equals. Everybody get an answer on your calculator right now. Practice it now. So you are not asking me how I do this. Especially if you were not here yesterday. $4.19? 5.19. That is correct. On my calculator, as you can see, when I hit the buttons, it writes the word. So I go in the order I see it. 25 sine 12. Now, I don't need to close this bracket, but I want to get in that habit because trig gets more complicated. Right now, we're doing one step of trig, right? So I get in the habit of closing that bracket. 5.19, which we are going to round to 5.2. Is everybody good? Even if you were not here yesterday, you should be okay. You just don't know why all this works. But you can watch the video and figure it out. Let's look at the second one. Do I have a theta? 19, which means this is the corner that I am looking at. Once I am there, I have to set it up. What is 40? Adjacent equals 40. What is this side? Hypotenuse equals X. What uses A and H? Cos. Cos theta equals A over H. Fill in the numbers. Cosine of what? $19 equals what? 40 over X. Now, you're intelligent young people. Yesterday we did this algebra the long way. I'm doing the shortcut today. X equals 40 over cos 19. If you're going to punch that into your calculator and you have a backwards calculator, it's 40 divided by 19 cos equals. For those of you with a forward calculator, 40 divided by cos 19, close brackets, equals. And everybody try it, and somebody say an answer. Does that make sense? Is 42 longer than 40? Because it's the hypotenuse, yes? And since this is only 19 degrees, this can't be very long, right? So this can't be much longer than 40. And is 42 much longer than 40? So we're probably right. What'd you say it was? 42.3? Let's check. 40 screw it. All right, 40 divided by cos 19. And I'm going to close my bracket. 42.3. Everybody good? Even backwards calculator people and people using their phones. Are you good? Excellent. Let's look at the next one. Do I have a theta? I do not. X. But that means that's the corner I'm looking at. What is the 13? Adjacent equals 13. What is the 22? That's hypotenuse. What uses A and H? Cos of theta, which is x, we don't know, equals 13 over 22. When I don't know the angle, I have to use shift cos, depending on your calculator. Some of your calculators will have a button with an S on it. Some of your calculators will have a button that has a little second on it. Some of you will have one that will have second F on it. Some of you will have one that is an I. There's all kinds of different calculators, but what you need to do is find your button that does that. And then you push shift cos, bracket, or maybe you don't need to put the bracket in, 13 divided by 22, close brackets, equals. And tell me what x is. Pardon me? If it's an angle, we round to the nearest degree. So it is 54. Let's check. Shift cos. Mine gives me the bracket. 13 divided by 22. I close brackets because I want to get in that habit. 53.77, which is 54 degrees. Is everybody cool? Please notice we have done every single question the same way. If you set it up and you know this, which I am not even going to make you memorize because it's on the sheet I gave you, can you do trig wrong? It's almost impossible, isn't it? Now, you will notice on the next 3 pages of your book are some of these puzzle sheets. All right? That's what you're going to work on for the rest of today and on Monday when you finish your test early, because you all will. Everybody cool? All right, so now this is work 2, because I gave you that page on tangent already, yes? Do this. Monday we write our test. Tuesday we finish with trig. Now, listen to me closely. You people are writing your final on Thursday of next week, yes? So you're block C. I'm sorry. You're writing it on Monday morning. But you all requested that we write it on Monday afternoon, so your brains are more awake. I do not mind that. But the next thing that every kid asks, Mr. Myers, can we get a review package? of course, you are carrying around a 300-page review package, because I got all kinds of data that shows ain't not one of you done every question in that book. There's crap tons of review for you to work on. Also, you have your cumulatives to look at. But because I am the nicest guy in the world, I also have online a package of review. It's like 40 pages. I'll give you the link. If you want it, you can download it. It's a PDF. If you only want to look at one or two sections of it, then only look at one or two sections of it. Some of them have answers, some of them don't, but it's there for you. Now listen. On Monday of next week, so 10 days hence, I will be here all morning because this is my job. You can come and spend any amount of time with me Monday morning. But listen, because you have made this decision to write your test in the afternoon, you all have to come to write it. Don't come in here at 9 a.m. on Monday saying, oh, all right, the final now. Because you can't. All right? Your final will start at 11:45 on Monday, January 27th. Okay? Everybody understand? Now, if you are in danger or near failing and you pass your final, all is forgiven. You can pass the year. If you are in danger of failing and you fail your final, well, then you're in a bit of trouble. So figure it out. Okay? Everybody understand? Am I going to be in this room every single afternoon on the 23rd, 24th, 27th, 28th, 29th, and 30th? Yes. If you have an A and you come in here and you say, Mr. Myers, I want a better A, will I be happy? Will I be happy? No. Okay. Those afternoons are for credit recovery, not credit I want to do better. You've had 4 months to do better. Aight? Aight. You got half an hour to work on your trig. Get going.